Hi, and welcome to this on-demand session titled Your Journey to Temporary Credentials in the Cloud. I'm Chris Lamont-Smith, Senior Security Consultant.
And I'm Meg Padada, a Senior Security Consultant, and we both work in the AWS Professional Services team.
If you're watching this video, there's a good chance you work in an environment where time and effort is spent trying to manage an increasing number of access keys. So this presentation is aimed at assisting the cloud platform teams out there who receive notifications that access keys on their platform haven't been rotated and want to know how to address them. It's also for engineering teams who work directly in AWS accounts, creating and managing access keys, and who want to find ways to make it easier. And it's for the account or product owners who want to understand more about the risks associated with access keys being used across their environments. In this session, we take you on a journey to help you reduce the number of access keys in your environment, and for the ones you need to keep, make it easier and less time-consuming to manage them. We'll start with a quick recap of IAM Access Keys, and then move on to discuss some of the risks associated with long-lived credentials and the challenges people sometimes face when making sure they get rotated. We then introduce a simple method and tool you can use to prioritize keys that are the most business critical, and we discuss alternative solutions you can use in place of access keys. Finally, we go over ways you can use automation to make the governance of access keys easier and less time-consuming, so you can focus on more important things.
But before we get started, you may have seen a great talk from last year's AWS Reinforce titled Using Short-Lived Credentials Everywhere on AWS, where our colleagues discussed the benefits of temporary credentials and the role of STS in issuing short-term credentials. It was a great talk, and the slides are still available, and recommend you take a look if you haven't already. We will be building upon these concepts and explaining how you can start applying short-term credentials in your environment. So, let's start our journey with a little recap on IAM Access Keys. IAM Access Keys are long-term credentials for an IAM user or the AWS account root user. They are made up of an access key ID and secret access key. You can usually find them in your AWS credentials file. They're used to sign requests made to AWS Service APIs, and signing these requests allows us to verify the identity of the requester, protect data in transit, and protect against replay attacks. They can either be used by humans or machines, and each IAM user can have up to 2 access keys, and the best practice states that the access keys are rotated every 90 days.
Now, when IAM access keys are managed well and regularly rotated, they're not a problem. And when we say rotating access keys, what we're talking about is the process whereby a new access key is created to replace an existing one, and that key is then disabled and eventually deleted. By rotating a key, we limit its lifespan, which reduces risk should it ever be compromised. But when they're not rotated, they become long-lived credentials, and these carry a number of risks. Users who at one point may have had legitimate access to a key could have changed roles or even companies, and they'll still retain that access. The longer the lifespan of an unrotated key, the higher the risk of compromise from such things as credential theft from a server or laptop, or the accidental leaking of credentials in code. Access keys can't be strengthened by using additional factors for authentication, like a hardware MFA token. And by default, access keys can be used from anywhere unless you set a policy to restrict their use to a source IP or network. So we've discussed the risks of having long-lived credentials. So the simple solution to that is just rotate your keys, right? Well, some customers have told us that they sometimes face some internal challenges that can make that difficult. For example, you may have keys that were created a long time ago and where the purpose and owner of the key is unknown. You might not have a defined process, so no one really knows what steps are involved in rotating a key or who needs to take action. Rotating a key might be perceived as simply the time to change your password problem, resulting in it being deprioritized in favor of other initiatives. Or you end up with a long list of keys that need to be rotated, but there's no idea of the risks associated with any of them, so it's difficult to know which ones to focus on first. And simply, the sheer size of the problem of rotating hundreds of access keys is a daunting one, making it hard to get started.
So you must be wondering, what steps do I need to take in order to be successful when reducing access keys in my environment? Well, today you're in luck, as we have narrowed it down to 5 simple steps. First, you want to prioritize. You want to take inventory of your access keys and prioritize the risk based on the business criticality. This step helps you get started on what's important. Second, you want to reduce. When working with keys on a large scale, it can be overwhelming. You need to reduce and remove access keys that are not being used. Third, you want to assess. You need to consider other mechanisms that can be used in place of access keys that provide short-term credentials. Fourth, replace. Now that you've decided on some options, you need to test and implement these solutions. And this might be the longest step in the journey, but investing time is well worth in the long term. Finally, you want to govern. You need to tackle cases where access keys need to be retained, and in that scenario, we focus on uplifting our policies and automating controls as much as possible. So, let's get started.
So the first step is to prioritize. This is important because if we have a large number of keys, it allows us to focus on addressing those that carry the most risk or have the biggest impact first. One way we can do this is by taking the information that we have on keys and enriching it with business data to give the keys more context as to where or how they're being used. So let's say we're a cloud platform team and we've received a trusted advisor report for our AWS organization that shows we have roughly 600 access keys that haven't been rotated in the recommended 90-day time frame. Now, 600 keys in a list doesn't tell us a whole lot about what they're for or the inherent risks of any of them. So what we really need to do is to correlate that list against data we might have about the accounts that the keys reside in, and use that to help us identify where to start. Now, what kind of data are we looking for? Well, that depends on what's important in your environment. You might want to prioritize keys that are used supporting business production workloads, or maybe you want to focus on a list of critical business applications over those used for back-end admin services. You might even want to focus on keys that are in accounts that are processing or storing certain types of data, such as PII. Now, how would we do this? So let's take that list of 600 keys and let's export that into an Amazon S3 bucket in JSON or CSV format. Next, we do the same with our business data. This could be from an extract from your change management database or CMDB. Or if you're following the AWS best practice for tagging, you might have this data contained within tags attached to your accounts that you can query from your AWS organization. Once we have the data in a place we can work with it, all we need to then do is leverage a service like Amazon Athena to join and filter the data on the attributes that are important to us. You might even choose to use Amazon QuickSight to make it easy to present and share the correlated data. So in our example, let's say we just want to focus on keys that reside in production accounts first. We can use the environment attribute to filter on just that criteria. However, this could just as easily be any other attribute of your choosing. To help get you started, we've released some code to go with this session that automates the steps I just discussed. The code has been designed to discover active IAM access keys within an AWS organization and to enrich them with business data about the AWS accounts they reside in. The tool extracts this business data from account tags as well as the location of the account within the AWS organization. It correlates the access key and tag data and outputs a CSV file that you can then query and filter using Amazon Athena or your favorite cloud or desktop spreadsheet application. In addition, the tool does some basic analysis of the permissions that are attached to the keys. For example, it will highlight if a key has powerful permissions, such as the administrator access policy, or if it's able to read from your data storage services such as Amazon S3, Amazon RDS, or Amazon DynamoDB. You can then use this information to assess the risks of the access keys identified by the tool. The code's being released on the AWS Samples GitHub repository, and I highly encourage you to download it and give it a spin. So in summary, to get you started, take your list of access keys and enrich them with business context so you can focus on addressing the keys that have the greatest business impact.
So moving to step 2, reduce. Let's switch our persona and imagine you're the cloud engineering team now who has been notified through the cloud platform teams that you have over 200 unrotated access keys across 10 accounts that you manage. In order to easily reduce the risk of these unrotated keys, one quick method is to remove access keys that have not been used in a long time. Often keys might be created for proof of concepts or pilots that are no longer required, By reducing these unused keys, you can instantly reduce the risk of the key that are left unmanaged. One way to reduce the scope of access keys you need to work with is by using the output from the tool we looked at before, or even something simple like IAM credential reports, which can be found under the AWS IAM service. A truncated version of the report can be seen in this table. It contains useful information such as the user, the ARN, the access key details such as whether it was last active, last rotated, last used region, last used service, and similar details if there's a second access key for that user. Now, as a cloud engineering team, you should have some context on the usage of these keys and why they might have been created. From the report, you can easily filter on keys that have not been used over 90 days, or in some cases, like this example, it had not been used in over 250 days, which is quite some time ago now. We can see that the last used service was AWS STS, and the region was AP Southeast 2 or Sydney. In this case, you should be looking to deactivate the key first by engaging with the right team members to make sure that the deactivation of the key does not impact any application or process. And once a period of time passes, you would be in a good place to delete this unused access key. Now, practically, this can be done by the console by navigating to the IAM service, selecting the user, and going to the security credential page where it shows you a list of access keys. In most cases, there's always only 2 access keys, and you can proceed to deactivate the unused key. Alternatively, if you're comfortable and familiar with the command line or CLI, here is a simple command to help you deactivate the key by saying AWS IAM update access key, saying the access key ID, changing the status to inactive, and also the username. So, often in most cases, we see that this is just a hygiene problem of unused access keys being left over in the environment. Therefore, one quick way to significantly reduce risk is by disabling keys that are not being used. Now that we've hopefully reduced a good chunk of unused access keys, what can we do about the rest of them? We should be looking to assess and replace them. The first question to ask yourself is, can they be replaced by an IAM role? But before we look at our options, let's explore what are IAM roles and why they are awesome. An IAM role is an object in AWS Identity and Access Management that is assigned permissions. When you assume that role using an IAM identity or an identity from outside of AWS, it provides you with temporary security credentials for your role session. Now you ask, why are they awesome? First, they allow users, services, and third parties to gain access to an account and its resources. Second, they use temporary credentials, which, as we know, have the following benefits. You don't have to distribute or embed credentials in your application. You can provide access to AWS resources without having to define an AWS identity for them. And given that they're temporary, they're time-bound and cannot be used once the credentials expire. Similar to the shared responsibility model, the temporary credentials are managed and rotated for you, reducing operational burden. Next thing you might wonder is, how does IAM role get these temporary credentials? Well, they talk to AWS Security Token Service, or AWS SDS, a service which is known for granting these temporary credentials, which can be used for federation, delegation, or cross-account access. One common example would be when using an Amazon Elastic Cloud Compute, or also known as EC2. Say, for example, your application needs to access a simple storage bucket or S3 bucket to retrieve some photos. Then you would need to give the EC2 instance a service role that has permissions to access the desired bucket. Now that we have some context on how IAM roles work, let's look at some services that use IAM roles that can help replace long-term credentials with short-term credentials. Now, starting with AWS IAM Identity Center, or previously known as AWS Single Sign-On. It helps you securely create or connect your workforce identities and manage their access centrally across AWS accounts and applications. Next, we have IAM Roles Anywhere. A feature launched recently used to retrieve temporary credentials using public key infrastructure for services, containers, and applications that run outside AWS. And finally, Systems Manager, a service which uses an agent-based mechanism to get temporary credentials that can be used to perform all AWS-like functions, just like an EC2 instance. So, the bottom line is to choose IAM roles over IAM access keys whenever and wherever possible. Now that you know a bit about these services, let's dive deep into how these services can help you reduce access keys. So our first use case is looking at humans accessing AWS. As a cloud platform user who is looking to streamline access for all users, this simple solution should solve most, and if not all, use cases for human access. Say, for example, you're an everyday developer who needs to access AWS to perform some DevOps activities. What does the flow look like? The user logs in to their existing identity provider, which then federates to AWS IAM Identity Center, where the cloud platform team has configured IAM roles and policies that are map them to their desired accounts. Once the developer assumes this assigned role, they are granted temporary access key and secret key, which provides them access to AWS via the command line interface or CLI. And one of the additional benefits of using AWS IAM Identity Center is that there is no cost for using this service. And now that we know how it works, let's look at how a user would actually grab these temporary credentials for their session. If you're using IAM Identity Center, then you can either programmatically configure your settings in the terminal by typing AWS configure SSO and then following the prompts, or you can grab the temporary credentials via the console if being used for a short period. Then navigate to the console, click Command Line or Programmatic Access, which gives you the second image on the right, where you can just copy-paste the variables into the command line. So one thing all platform teams should be aware of is that users should not have long-term credentials, and I would highly encourage teams to review their IAM users and replace their long-term credentials with short-term or temporary credentials. Now that the easy part is over, let's get a bit more technical with machine access. As part of your journey in the cloud platform team, you would also be considering what are some better solutions when granting the on-premises servers access to AWS resources, in which case we can consider two options. IAM Roles Anywhere, an extension to IAM Role that uses public key infrastructure to gain access to AWS. To make this viable, your workloads need to be using X509 certificates that have been issued by your certificate authority. This certificate authority is then used as a trust anchor with IAM Roles Anywhere. This can also be used with AWS Private Certificate Authority. To get temporary credentials, you need to use the Credential Helper tool provided by the IAM Roles Anywhere. This helper can then manage the process of creating the signature with the certificate and then calls the endpoint to get the session credentials. You may say, that is great information, but my application does not handle certificates yet. Well then, let's look at our alternative option, which is using Systems Manager, another cost-free service that allows easy management of your fleet in and outside of AWS with the use of a simple agent. Now, to configure IAM Roles Anywhere, first, we need to establish a trust between your private CA and the IAM roles. Then, create an IAM role specific to your requirements or use an existing role and update the trust policy to include the following. You need to allow the service rolesanywhere.amazonaws.com and then configure a condition that allows specific certificates to assume that role. Now, if certificates don't work for you, we can look at creating a Systems Manager activation, which allows users to centrally manage hybrid environments from one location. Simply install and configure the agent on your server, and you're ready to go. So now that we've covered a lot of technical concepts, and it might seem like a lot, I would suggest you just take action and test these services.
Okay, so we've prioritized our keys using business context, we've removed those that are not needed, and we've assessed and replaced access keys for better role-based mechanisms. But what do we do about the keys we can't get rid of? How do we ensure we don't end up back here again in the future with another massive list of access keys needing to be managed? Well, this brings us to step 5, govern, where there are two primary things you can do starting today to help make sure that won't happen. Number 1, make sure that the policies and processes around managing access keys are well defined and that people are aware of their responsibilities. And 2, use automation as much as possible to enforce policies and streamline processes. This will greatly reduce the amount of human involvement needed to manage keys and will let you get on doing more important things. So what sort of things should be part of your access key management policies? Well, let's consider the example of John. He's a product owner and he's responsible for 5 development teams operating across 20 AWS accounts. John is concerned that his developers are routinely creating access keys to allow a remote third-party IT support company to access his accounts when troubleshooting issues. It's also not uncommon for keys to remain active even after an issue has been resolved. And when John looks at the many user accounts that have access keys attached, he's unclear which ones are in use or for what purpose. When John recently reviewed IAM credential reports for his accounts, he noticed usernames that he recognised as being for external system access, and although the access keys showed they are regularly used, they hadn't been rotated in over a year. And when John checked the IAM policies attached to some of those system users, he was surprised to find that at least a few of them had high levels of access that, if compromised, could seriously impact his business operations. When John asked his team about getting them rotated, in many cases his developers didn't know what those systems did or how to update the keys on them. Now, to help fix this situation, John should consider uplifting some of the policies and processes around access key management to include the following. He could require that approval be sought for the creation of access keys. He could make sure that each key has an owner, a purpose for its use, and business impact defined. And when we talk about business impact, we mean what is the worst that could happen if the key were to be compromised. He should ensure that responsibilities around key management are clearly documented. He should consider putting a time limit on how long a user account can be used before it needs to be reviewed. And John should require that all access keys have an automated mechanism in place that ensures rotation happens with as little human involvement as possible. This could be a fully automated rotation process, or it could be as simple as raising a ticket to instruct a team to do the work. And lastly, he might want to mandate that IAM access keys are only to be granted for machine or programmatic access. Now, once John's uplifted his key management policies and processes, he can then start to consider how he can best leverage automation to make sure his policies are followed. We're now going to go through a few examples of how you can use automation to help enforce your policies. One method to consider is to centralize and automate the access key creation process. And this is how it might work. Let's say you require an access key for your application. You're able to go to a self-service portal where you can raise a request for a key to be created on your behalf. You simply supply the information needed to create the key, and this kicks off an automated workflow that notifies relevant stakeholders who need to review or approve the request. It registers the key and associated metadata in a central asset registry that helps with managing and tracking keys. It performs security checks, such as assessing the permissions the user account associated with that key might have. And finally, once the workflow is complete, it creates the access key for you and provides you the secret key by storing it in AWS Secrets Manager, where only you can access it. To ensure that users cannot simply bypass the service and create access keys manually, service control policies are used to restrict the action of key creation so that they can only be performed by the automated workflow. However, if you're just looking for better ways to detect and respond when keys aren't being rotated, you might want to consider using AWS Config. With AWS Config, you can configure a periodic rule to check if an access key has not been rotated within a time frame that you specify, and it'll be raised as a security finding in AWS Security Hub. You can use the AWS Security Hub finding to trigger automation and raise a risk in your risk management system. This will notify various stakeholder teams of policy non-compliance. Additionally, you can also raise a ticket with the owner of the key, instructing them to take action to rotate it and remediate the risk. In fact, this is a common monitoring pattern you can use to check for other things like making sure user accounts with access keys are tagged with required metadata, checking if the permissions of a user account that has an access key have changed since the key was created, or initiating a periodic review of a user account to ensure it still requires an access key. Now, another place where automation can be beneficial is for reducing human involvement in the actual rotation of access keys. So you might want to look at automating common key rotation scenarios. Let's say we need to periodically rotate an access key that our SaaS application, or software as a service, is using to access our AWS account. We can do this using AWS Lambda with AWS Event Bridge. We schedule Event Bridge to invoke our Lambda function once a month, let's say, and the Lambda function will perform the rotation for us. The Lambda is able to log into the SaaS application by retrieving credentials stored in AWS Secrets Manager, and can also interact with IAM to create the new access key and disable the old one. We can even go further to configure the Lambda to not only rotate the IAM access key, but the credentials used for the SaaS application itself. Now, if you work in an environment where there are a large number of access keys, and the teams who own those keys are finding it difficult to stay on top of keeping them rotated, you could look at ways to gamify the process to help encourage people to get the work done. For example, through automation, you could create real-time leaderboards using AWS Security Hub and Amazon QuickSight, which would highlight which accounts are doing well with managing their keys and which ones are falling behind. This will add a competitive spin on the problem and encourage teams to take more of an active role in access key management activities. So for step 5, govern, use automation to enforce policy and make IAM access key management easy. So to summarise, let's do a recap of the 5 steps we want you to take away. Number 1, prioritise. Get started by taking your list of access keys and enrich them with business context so you can focus on the keys that have the greatest business impact. Scan this QR code and it will take you to the AWS Samples GitHub repository where you can download the tool and get started today. 2, reduce. Disable keys that you're not using to reduce your risk. 3, assess. Look at IAM role-based solutions to use in place of access keys, such as AWS IAM Identity Center, IAM Roles Anywhere, and AWS Systems Manager. Number 4, replace. Get executive support if you need it, test the solutions, implement them. Basically, take action. And 5, govern. Update and clarify your policies around access key management, and then automate as much of the processes as possible. This will save you time and effort in the long run.
To learn more about the services we talked about today, or increasing your technical skills, visit Skill Builder, our online center, and explore over 600 free digital courses, hands-on labs, and role-based games. We thank you for joining the session today. Please feel free to connect with us on LinkedIn, and as usual, we really value your feedback to help us improve our sessions.